In this section, we'll talk about parent relationship. Parent relationship is one of the most basic and most important concepts in rigging. You could say lots of rigging knowledge is built on this idea. The parent relationship is essentially a form of hierarchy or dependency. The parent object controls the child object, while the child lives under the parent and has its own relative space of movement. This may sound dry and hard to grasp, so let's use a simple example to make it easier to understand. First, let's draw a 2D coordinate system. And at the origin point 0, 0, we place a small car. Then we put a little character inside the car. Now let's move the car 10 units along the x-axis. So the car's position becomes 10, 0. And since the character is sitting in the car, he actually has two position relationships. One is his world position. The other is his relative position to the car. Let's look at the world position first. Since the person in the car didn't move at all, he is simply sitting in the car. So his world position matches the car at 10, 0. But his relative position, because he hasn't moved inside the car, his relative position is still 0, 0. That's actually quite easy to understand. When we sit in a car without moving, we still arrive at the destination. So the relative position is 0, 0, but our world position becomes 10, 0. Now let's make it a bit more complex. Let's say the character in the car feels tired. He wants to move around inside the car. So now we let him walk 1 unit toward the back of the car. Let's look at his relative position first. That relative position will definitely change. Originally, he wasn't moving at all. Now he moves 1 unit backward inside the car. So his relative position becomes -1, 0. Meanwhile, his world position also changes, because he's moved along with the car 10 units first, then moved 1 more unit toward the back. So his world position becomes 9, 0. This is a very simple example of parent relationship. Here we can say that the car is the parent object of the character, and the character is the child of the car. As we can see, when the car, which is the parent object, moves, the child follows. And when the character moves inside the car, he still has his own relative movement space. That is, the child moves within the parent space. There's one more thing to note here. The parent hierarchy affects not only position, but also rotation and scale. Let's continue to look at rotation in this 2D coordinate system. To make it easier to see, we'll draw the car's own local axis too. We know that our character has always been inside the car. So for him, regarding world direction and position, he doesn't have much concept of it. His reference is actually the car itself. So according to this positional relationship, we take the car's front as its x-axis and the car's top as its y-axis. Now let's rotate the car upward by 90 degrees. We can imagine the car would now look like this, and the character would also look like this. We still mark the coordinate axis here. At this point, if we make the character move inside the car again, we will notice something a bit different from before. We still make the character walk toward the front of the car, for example, 2 units. Now think about it. The relative position is still calculated between the character and the car. So no matter how the car rotates or moves, the character still walks 2 units toward the front of the car. So the relative position here is still 2, 0. However, when we consider the world position now, it becomes different. Because we know that in world coordinates, this upward direction is the y-axis. And now for the car, its upward direction corresponds to the x-axis. So in world space, if we say from the origin, let the character walk 2 units toward the front of the car. But since the car has already rotated 90 degrees, in world position, the character is actually moving upward 2 units. So now it is 0, 2. This is also a feature of the parent relationship. Our child object does not use the world directions as reference. It uses its parent object's own directions. Let's look again here. It has rotated 90 degrees. It's the car's own directions that has changed by 90 degrees. But for the character, nothing has changed. So his relative position is still along x and y axis. But relative to the world, his x and y axis have rotated relative to the world axis. Now let's map all these things into 3D space. In 3D, in the channel box, we have translate, rotate, and scale. We have translate XYZ, rotate XYZ, and scale XYZ. The default values are 0, 0, 0, 0, 0, 0, 1, 1, 1. Here, we should note that the values shown in the channel box are always relative positions. They are always the position relative to the parent object, and their directions are also based on the parents. They have nothing to do with world position. Of course, some may ask, what if the object doesn't have any parent? Then it still shows a relative position. But since it has no parent, its parent is the world directions. So its directions and position, relative and world position, relative and world coordinates completely overlap. So in that case, the relative position equals the world position. Now let's return to Maya to verify the parent relationship concepts we just discussed in 2D. We can see in my scene there is a car, and inside the car there is a character. The character now exists as a child object of the car. We can see that when the car moves, the character moves along with it. Here we should pay attention to the values in the channel box. Here's a piece of advice. As riggers, we must be sensitive to every single value. I know that before, when learning modeling or animation, we might have focused more on the result of translating, rotating, and scaling handles. But in rigging, we must also pay close attention to the value changes of each attribute. As for why this is important, we'll explain more in later chapters. But for now, let's look here. This car, let's make it as before, move forward 10 units. We can see that the character in terms of world position has also moved 10 units. But we can see that his translate, rotate, and scale values haven't changed. However, if we say the character now walks 1 unit toward the back of the car, we'll see that his value now shows -1. And in world position, if we count the grid units, 1, 2, 3, 4, 5, 6, 7, 8, 9 units, then in world space, he is now at 9 units. Let's continue as before. Let's rotate the car 90 degrees. Then we'll see that when we move the car again, it still moves in world space. But when we move the character, we'll notice he's still moving along the car's z-axis. For example, when we move forward 2 units, although in world space, we can see this is the world coordinate axis. The upward direction is the y-axis, but relative to the car, it's still the front, still the z-axis. So we'll see that in the channel box, the z-axis value has increased by 2. Next, let's talk about how to create parent relationship. First, I'll unparent all these objects. Now we want the character to become the child of the car. The selection order is very important here. In Maya, we select the child first, then the parent. So we select the character first, hold Shift, and select the car. Then go to the Edit menu and choose Parent. We'll see the shortcut key is P. We can click that, or undo. Select both again and press P on the keyboard, it's the same. Also pay attention to the outliner. In the outliner, these two objects were originally at the same level. When I press P, one will move under the other. This tree structure in the outliner represents their parent hierarchy. The upper object represents the parent, the lower one is its child. This gives us the same result as before. So what if we want to remove the parent relationship? Select our child object, then go to Edit and find Unparent. And as we can see, its shortcut key is Shift plus P. So we select our child object and press Shift plus P. Then, in the outliner, we'll notice the tree hierarchy between them no longer exists. We can not only adjust parent hierarchies directly in the viewport, we can also do it manually inside the outliner. For example, if we want to select our child object, this character, and add him into the car, we can select the character, hold the middle mouse button, and drag him in. That will also create a parent relationship. Likewise, if we want to remove it, we can drag it out again. But since I have nothing below here, dragging it out can be a bit tricky. So we can drag it upward instead. That will also remove the parent relationship. Now, some of you might ask, what happens when we have multiple objects? Well, parent relationships, as the name suggests, are just like real life. A parent can have multiple children, but a child can have only one parent. So the same rule applies here in Maya. A parent object can have many children, but a child object can only have one parent. When we select multiple objects, for example, select our character and also this 2D coordinate object here, then additionally select our car and press P. Maya will automatically make all previously selected objects under the last object we selected. They become children of the last selected object. If we select those again and press Shift plus P, it will remove their parent relationships together. And the same applies in the outliner. In the outliner, for example, if I create a few more objects, just keep in mind this works the same way as in the Windows File Explorer interface. If we select one and hold Shift to select, it selects everything within that range. But if we only want to select 2 or 3 specific ones, we can hold Ctrl to multi-select in the outliner. Then, as before, select the last one and press P to create the hierarchy. Or we can also drag with the middle mouse button to form the parent relationship. Next, let's talk about some common operations used with parenting. Some of them apply in the viewport, and some are for the outliner. Personally, I find all of them very convenient and useful. First, look at my outliner. Here I have several groups. These groups have hierarchical relationships, and I have 3 models as their child objects. The first thing we'll talk about is this. Looking at this tree structure, we can left-click with the mouse to open it up, and click again to collapse it. Open it again, then close and reopen it. Now here, there's another handy shortcut. If we hold Shift and close it, then what happens is it will close all of them by default. Next time when we left-click to open, we can only open them one by one. And once we open them again, the outliner remembers that state. If next time we want to close them and keep only one open, hold Shift and collapse it again. That way, the next time we open the outliner, it will only show one. By the same logic, when we hold Shift and click to expand the tree hierarchies, the outliner will expand all and display them completely. Then the next time we click again, it remembers the last open state. That's the first useful operation. Now the second operation. First, let's close them all. Say we've selected one model, or any node. Can we quickly locate it in the outliner? Yes, we can. In the viewport, we know pressing F will focus on the selected object. This works the same way in the outliner. Select the object you want, then make sure your mouse is over the outliner panel. Now press F on your keyboard. By doing that, it quickly scrolls the outliner to show the selected node's position. Note here, it won't automatically expand the lower hierarchies. For example, if I create a few more groups and place them under this model as children, then hold Shift to close them all. We'll see when I select the model and press F. It will show just that model without expanding the layers underneath. Of course, if those hierarchies were already open, then pressing F again will keep that open state as before. Another useful thing to know when we've selected a node. How can we quickly find its parent, its child, or the objects at the same level? Maya gives us a very handy shortcut for that. Look at the outliner here. It shows a hierarchy. When switching between parent and child levels, it follows the same order as the outliner, up and down. So when we select an object and press the up arrow key, we can find its parent level. Press up again to go another level higher. We can keep pressing to reach the topmost parent. Of course, once we reach the top object that has no more parents, pressing up won't do anything. When we press the down arrow, it jumps to that parent's first child. That lets us find the corresponding child object. At the same level, we can use left and right arrows to switch between them. When we press right, at the same level, switch downward in the outliner. When we press left, it goes in reverse order. Switch upward in the outliner. This function in Maya is called pick walk. It's a very convenient feature when we're doing rigging work, especially when we start creating relatively complex rigs later on. Sometimes we'll need to troubleshoot certain errors. There might be a large number of nodes in our scene, and there may also be many items in the outliner. So even without looking at the outliner, we can select an object, then press the up arrow to quickly locate its corresponding parent level. This is actually a very handy shortcut. That concludes our explanation of the parent relationship concept. As we mentioned at the beginning, The pair relationship is both a fundamental and crucial concept in rigging. We really need to understand it. Of course, in the upcoming practice sessions, we'll keep applying this concept to help everyone grasp it more thoroughly. See you in the next video.